6.2 is about multiplying and dividing radicals. Okay, yesterday was just kind of our lesson 6.1 introduction, just dealing with radicals in general. Lesson 6.2, officially it says multiplying and dividing radical expressions. Now, if you ask me, before you can multiply and divide radical expressions, you have to know how to simplify them. Okay? And I feel like this book, they throw in simplifying here. They just kind of assume you remember how to simplify radicals from Algebra 1. I know better than to assume that you guys remember how to simplify radicals from Algebra 1. So we will be starting in the area of simplifying. And I will tell you guys, there are a few of these problems I'm going to tweak, change slightly on the go because I want to make them fit my needs better. So just kind of an FYI there that, if I change a problem, it's because I want to. Teacher prerogative, so to speak. Okay, before we get started, properties of radicals. There's two properties up here, and it's basically just helping us to understand when can I multiply and divide radicals and when can't I multiply and divide radicals. And if you look here, the first one, if the nth root of a and the nth root of b are real numbers, then the nth root of a times the nth root of b equals the nth root of ab. What is that pointing out there? In order to multiply radicals, what has to be the same? The n, whatever root it is. Okay, so right there, in order to multiply radicals, those little numbers have to be the same. Okay, we call them the index or the root. So what that's saying is, okay, if they're both 2's, you can multiply a square root times a square root. You can multiply a cube root times a cube root, a fourth root times a fourth root. What you can't do is you can't multiply a square root times a cube root. Okay, so those have to be the same. It doesn't matter what's underneath. Okay, a times b is just ab. You just multiply whatever it is. But the key is the indexes have to be the same. The second property here is just talking about division. If the nth root of a and the nth root of b are real numbers, then the nth root of a divided by the nth root of b is the nth root of a divided by b. So again, it's just saying as long as they're the same type of root, so that index number is the same, we can multiply and we can divide. So, example 1 is just kind of processing that step right there. So look at example 1a. Can you simplify the product and explain? So a, what is the cube root of 6 times the square root of 2? Can't do it? Why can't I do it? Okay. This one's a cube root. It has an index of 3. What's my invisible number right here? 2. Invisible number 2. And the rule says, in order to multiply, they have to have the same. So, can you simplify? The answer is no. My explanation, I'm going to use the word indexes. If you prefer, though, you could say roots. So the indexes or roots are different. So you just have to leave your answer like that. You can't go any farther. What about b? The cube root of negative 4 times the cube root of 2. He says the cube root of negative 8, maybe. Can I multiply them is the key.
Yes.
Yes, because they are both cube roots. So officially, can you simplify? I'm going to say yes. And cube root of negative 4 times cube root of 2, I can agree, is cube root of negative 8. The question, as always, becomes, are we done? Can we do the cube root of negative 8? Yeah, it's one we've done, I think, the last 2 days, haven't we? Cube root of 8 is 2. Cube root of a negative is a negative. So this simplifies to be -2. And C, the fifth root of -5 times the fifth root of -2. I'm seeing some head nods. Yes, we can, because they are both fifth roots. So, yes. What's the fifth root of -5 times the fifth root of -2? The fifth root of 10, because -5 times -2 is +10. Am I done? Do we know the fifth root of 10? I don't know. Two times 2 is 4. Times 2 is 8. Times 2 is 16. I've already gone too far, haven't I? Times another 2 is 32. So common wrong answer is the fifth root of 10 2? No. It's not a power. We don't do 10 divided by 5 and get 2. Okay, the calculator says 1.58 something, something, something. So, can we do the fifth root of 10 just using our brains? No. The fifth root of 10 is simplified. It's a good one to talk about. Be careful, it's not at an exponent where you're just doing 10 divided by 5 like yesterday. It's a whole number. Okay, so you need those numbers to multiply. Okay, got the basics there, right? Okay, let's move to example 2A. And as we move to example 2A, teacher prerogative, we're changing this problem just a teensy bit. We're going to forget the cube, because I don't want to jump into cube root world right off the bat. I want to start in square root land. Okay? So you can white it out if you want. I'm not going to white it out on my end, because if I white it out and someone's later like, wait, why do you have that? Why do I have this in my notes and you don't? You can just see that I scribbled it out. I'm changing my mind. Okay? So our goal here is, what is the simplest form of square root of 54x to the fifth? So we did a little bit of this back when we had quadratic formula and we were simplifying square roots. Square root 54x to the fifth. Thoughts? Natalie? We will want to split 54 up. Why did you pick 2 and 27? Because what? They do multiply to be 54, but do 2 and 27 help me? In other words, can I take the square root of 2 or the square root of 27? If I was still talking cube roots, we'd have a discussion.
Yeah, that's why I was looking at.
But remember, I changed this to a square root problem. So change your brain to square root land. Because I do want to break 54 up, just not with 2 and 27, because I can't take the square root of either of those. Sierra? Why should we pick 9 and 6? 9's a perfect square. Does this sound familiar a little bit? You did it back in Algebra 1. I taught it a little bit with quadratic formula, right? Now I'm really teaching it. Okay, this is the time to get official. So, what I'm going to do is I'm going to take this square root and I'm going to break it down into pieces. I'm going to take everything I do and break it into perfect squares and not squares. So 54, it was suggested that we take 54 and break it into 9 times 6. Because 9 is a perfect square and 6 is just the remaining factor. Okay, so we'll finish cleaning that up in the next step. Let's move over and talk about x to the fifth. can I take the square root of x to the fifth? We talked yesterday about taking square roots of exponents. How did we take a square root of an exponent yesterday? We divided by that root or index. So in order to take the square root of x to the fifth, you take 5 and divide by 2. Does 5 nicely divide by 2? No. So we cannot take the square root of x to the fifth, but what we want to look at is other perfect squares in there. So 5 does not divide by 2. What is the next closest number below 5 that does divide by 2? 4. So I'm going to take my x and I'm going to break it into x to the fourth, which does divide by 2, and the leftover x to the first. So notice, all I've done is rewritten my expression. I have not changed the value at all, have I? 9 times 6 is still 54. X to the fourth times x to the first is still x to the fifth. All the pieces are still there. I've just rewritten it. But now we can do our simplifying when we take those perfect squares. Okay, square root of 9, what is it? 3. And when I take that square root, where do I put it? Outside. So the square root of 9 is 3, and 3 is no longer under the radical. Square root of 6. Not a perfect square. So what does that 6 do? It stays under the radical. The square root of x to the fourth. X squared, because what do? We divide that 4 by 2, and that's x squared. Where does that x squared go? Outside the radical. Square root of x to the first. 1 does not divide by 2 nicely, so we just leave x to the first under the radical. Which I'm just writing x. I put x to the first. I put x to the first up in my work just to try and make a point that 4 plus 1 is 5. All my x's are still there. But it's not that you have to write the x to the first. Do I have any perfect squares left in my square root? No. 6 isn't a perfect square. X isn't a perfect square. There's no perfect squares left in there. So I'm done. So we have final answer, 3x squared times the square root of 6x. Sound a little familiar? I mean, in all technicality, I taught a little bit about variables yesterday. I taught about something like 54 last semester when I taught quadratic formula. But we're putting it all together. Okay, ready to try B? Now, B I'm going to leave as a cube root. Okay, because I looked through the homework this morning, and of the 18 problems, I think I counted there was about 6 of them that involved cube roots. Okay, I think they're all either square roots or cube roots, if I recall correctly. But there was about 6 that were cube roots, so I can't just avoid cube roots. I just kind of want to take it easy and talk square roots first. Now let's talk cube roots. Okay? So B, the cube root of 128 x to the 7th. One of the first things I would always check, is 128 a perfect cube? And this is a day you're going to want your calculator by your side. Okay, so 128 is not a perfect cube. So, just like with the square roots, we have to figure out perfect cube roots that we can pull out. Now, 9 times 6, 9 you knew was a perfect square. That was a pretty easy perfect square. How well do you know your cubes? Well, okay, here's the deal. You've got to find a perfect cube that goes into 128. Did you find something, Ezra? He says 64.
I said 16.
Okay, so is 64 a perfect square? What's this cube? Not perfect square. Strike that. Is 64 a perfect cube?
Yes, it is.
4 times 4 is 16, times 4 is 64. So 64 is one of those weird ones. It's a perfect cube and a perfect square. Okay, but it's a perfect cube. So we can use 64 times what? 2? Now, Reese, you said you found 8 times 16.
Yeah, that's that.
But 8 is 8 a perfect cube?
Yes.
8 is a perfect cube. But here's the deal. You didn't get the biggest perfect cube. And I'm going to talk today as we go through some of these examples, options. I always suggest going for the biggest one. But if you don't find the biggest one, you can still go. Now, for the moment, I'm going to hand out these blue papers. Some of you won't need these blue papers as much as some of the rest of you will appreciate these blue papers. For those of you online, virtual, if I provided you notes, I have provided you a blue paper that was stuck inside the notes, so as long as it didn't get lost along the way. Let me explain my blue paper. I find it a handy-dandy teaching tool. Some of you will love it, some of you will never use it. Whatever. Here's the deal. I lost my blue paper. The small perfect squares, I expect you know. The small perfect cubes, some of you guys are like, yeah, I kind of know those. Some of you are like, maybe not. Can this paper help me? Yeah, because what have I listed here? Perfect squares, cubes, fourths, and fifths. Now, the problem we were working on was cubes, right? And so if I look at that cube column, I'm looking for perfect cubes in 128. Well, okay, those numbers are bigger than 128. Here are my options. 8, 27, 64, and 125. Do any of those divide into the 128? And this is where I grab my calculator. Let's see, does 128 divide by 125? No, I got a decimal. Does 128 divide by 64? If I hit the right number. Okay, and it does, right? So, I notice I started at the big end. I was working my way down because I want to make sure I try and find the largest one possible. So, I will use this, I'll explain this paper more in our next example too, but also notice, as you look at those cube roots, do you see what order I have those in? What's the cube root of 8? 2. Cube root of 27? 3. Cube root of 64? 4. 5. 6. 7. 8. 9. 10. So they're in order, yes? And these are your blue papers to keep. If you want to write what they equal next to them, that's your choice. I don't put them on there anymore because it got kind of confusing which numbers I was talking about when I put them on there. Did you see how I set up the square roots? Do I have them in order? Yeah, what's this first column? It's square roots from 2 through 10. And the second column is 11 through 20. Okay, they're in order. What about fourth roots and fifth roots? What did I give you there? Two, three, four, 5. 2, 3, 4, 5. I mean, I could keep going on all day listing things, but I tried to give the ones we'd use the most. Okay? So, your blue paper to keep. Okay? I would keep it with your notes. I think you'll find it helpful. I really do at times. Maybe you didn't need it on this problem, but you'll find it helpful at times. Okay. Let's go in and finish up this example now. Cube root So I might go back and write in that was a square root there. Okay, cube root. 128. We already decided 128 divides by 64. So I'm going to rewrite 128 as 64 times 2. Okay. X to the 7th. Can I take the cube root of x to the 7th? No, why not? Okay, 7 does not divide by 3. Next number below 7, closest to 7 that does divide by 3. What divides by 3? Is 6. So I'm going to break this x to the 7th into x to the 6th. And how many leftovers? X to the 1st. So do I still have all 7 x's there? I do. And again, it's not that you have to write the 1 on there. I just feel better when teaching. Okay, guys, let's do it. Cube root of 64. 4. So that 4 is going to go outside. Cube root of 2. It's going to get you a decimal, so it's going to go under the radical. Cube root of 2. Cube root of x to the 6th. What do I do with that 6? Divide by 3, and it's x to the 2nd. And that's now outside my radical. Cube root of x to the 1st. Stays x under the radical. Okay, got an idea? You've seen a square root, you've seen a cube root. Okay. If you don't have questions, I'm ready to try the next one and multiply. As we look at example 3a, I'm going to say that there are a couple of different ways I could teach this. How I teach it might be different from another teacher that teaches it, and it might all be different from how Math Excel teaches, because I never know what they're going to do. My technique here is that I usually teach that we're going to multiply these two together. We're going to get some big old radical, and then what are we going to have to do with that radical? Simplify it. So the steps we were just taking. Okay? That's my choice of how I teach this. Now, I've also seen, and I, understand, you could also instead simplify the first radical, simplify the second radical, and then multiply those two together. The only catch is if you do it that way, sometimes when you multiply them together to get 1 again, you have to end up simplifying a third time. Okay? So, there's no right or wrong, teaching method here. It's just a matter of what I choose to do. So just kind of beware that, if someone else helps you, they might have different thoughts. Maybe you'll like those thoughts better. Maybe you won't like what I do, but I don't know. Okay, example 3. Square root of 72x cubed y squared times square root of 10x y cubed. What do I get when I multiply? We're having to grab out the calculators. Okay, 72 times 10 is 720. X to the 3rd times x. X to the 4th. Y to the 2nd times y to the 3rd. Y to the 5th. Okay? If that is somehow all simplified, we're done. 720 is a big number, though. I'm going to guess that this square root is not simplified. Now, as you look at your paper, and I'm going to instruct you a little bit of how this paper can be helpful. Is 720 on this list? No, 720 is bigger than this list, but that's all right because we probably have big enough numbers. My technique, At least if you come to me totally confused and I'm trying to help unconfuse you and give you guys a process, here's what I'm going to do. I'm going to start big, and I'm looking for a number that divides by 720. The bigger, the better. So, does 720 divide by 400? Not evenly, right? Okay, so no, because it gives me a decimal. Okay, 400 didn't work. Now I'm going to try the next one. Does 720 divide by 361? No, I get a decimal. Does 720 divide by 324? No, I get a decimal. Does 720 divide by 289? Not evenly, I got a decimal. Does 720 divide by 256? No. Does 720 divide by 225? No. 720 divide by 196? No, I got a decimal. 720 divide by 169? No, I got a decimal. Does 720 divide by 144? Yes. And now, obviously, if you're doing that on your own, can you skip some of the obvious ones you knew wouldn't work, those type of things? You can. If you feel the need, if you don't see obvious ones and you feel the need to do all of them, do all of them, right? I try and make this technique so it works for all levels. Okay, we found 144 times 5. And why is 144 so helpful? It's a perfect square. Okay, so let me rewrite this by expanding it. Oops. Has a perfect square of 144, so we're going to say 144 times 5. Notice I'm not changing the value, I'm just rewriting it. Okay, next we have x to the 4th. Am I going to be able to take the square root of x to the 4th? Yeah. Yes, because 4 is even and will divide by 2. So I'm just going to leave that as x to the 4th right now. I'll come back and do square roots later. What about y to the 5th? Can I take the square root of y to the 5th? No, because 5 does not divide by 2. Closest number below 5 that does divide by 2. 4. So what am I going to do with this y? Yeah. It's going to be y to the 4th times y, the leftover y to the 1st. Because 4 does divide by 2. Okay, I got all my pieces broken up. Now we just have to finish it up. Square root of 144. 12. That's going to go outside. Square root of 5. Can't do it, so it's going to stay under the radical. Square root of x to the 4th. 4 divided by 2 is 2, so x to the 2nd, and that's now outside my radical. Square root of y to the 4th. Y to the 2nd, because 4 divided by 2 is 2. Square root of y to the 1st. Can't do it. 1 does not divide by 2, so this y to the 1st stays under the radical. Always check when you get done, were there any other perfect squares hanging out under my radical that I overlooked? Okay, does 5 have any perfect squares in it? Does y have any perfect squares in it? If they did, you'd have to keep looking for more perfect squares and maybe simplify again, okay? Or go back and do it from the beginning and do bigger. And I'll show you an example here on the next one, assuming time allows me. Okay, you got the idea of what I want you to do, right? Let's try B. What am I going to suggest you do first? Multiply them together. Hello. Okie dokie. You're welcome. Bye. Okay. What was that first step you were doing while I was on the phone? Multiplying them, right? 45 times 35. 1,575. X to the 6th. Y to the 7th. Because x to the 5th times x to the 1st is 6, and y to the 3rd times y to the 4th is 7. Well, I don't know about you guys, but 1,575 is a big number, yes? Now, you can, like last time, start trying all these numbers on the blue paper. I can also kind of jump around and try some things. I mean, 1575. This ends in 5, or it ends in 75. Okay. So I'm hearing some things there. I'm hearing a 225. Did anyone say 25? 25 works, but can you go bigger? 225, okay? And this, the blue paper gives you numbers to try, right? I don't know. Do you guys know 225 is a perfect square? You do now. Good answer, okay? So this is why I'm giving you the paper. Now, when I look at 1575 and I divide it by 225, I get 7. You think I got the largest perfect square? Does 7 have any perfect squares in it? No, 7 is a prime number. Whereas, if I had done 1575 divided by 25, I would have gotten 63. Well, you know what comes to my mind for 63? 9 times 7, which means I didn't get the biggest number. Okay, so that's one way you can kind of check yourself to see did we get the biggest number. Okay, so square roots. We already said 1575 is what? 225 times 7. Can I take the square root of x to the 6th? Does 6 divide by 2? Remember with powers, we're just dividing by the root. 6 divides by 2, so we'll leave x to the 6th. As long as it's even, it's good here. Y to the 7th. Can I take the square root of y to the 7th? No, 7 does not divide by 2. Closest number below 7 that divides by 2. Y to the 6th. So I'm going to break this up into y to the 6th times y to the 1st. Okay. Square root of 225. 15. That's going to go outside the radical. Square root of 7. Can't do it, so it's going to stay under the radical. Square root of x to the 6th. X to the 3rd, because we're going to divide by 2. It goes outside. Square root of y to the 6th. Y to the 3rd, because we divided by 2 again. Square root of y to the 1st. It stays y under the radical because I can't do it. 7 and y. Does it look like I have any perfect squares left there? Nope, that looks pretty good. Now, 2 things as just kind of a side note. I'm going to play the what if game with you for a moment. Hypothetical game. Just worried about 1575, not worried about variables. But what if, instead of finding 225, you didn't find 225 and you used 25? Then you would have had, it was what, 25 times 63, I believe? Okay, here's my deal. 25 is a perfect square, but what do I know about 63? There's a perfect square in it. So what I would suggest I mean, you can go back and look for a bigger, or we can keep going. 25 is a perfect square. That's good. 63 breaks down into 9 and 7. I have two perfect squares and a leftover. And we can do it this way. The square root of 25 is 5. That goes outside. The square root of 9 is 3. That goes outside. The square root of 7 stays square root of 7. Notice 5 times 3 is 15 square root of 7. Did I get the same answers I got over here? Yes. So it's not that you have to go back and find the biggest number. You just have to make sure you get all perfect squares out one way or another. Okay? Other thing I don't think I mentioned in this class today. We talked about absolute value a little bit yesterday, right? And I've kind of ignored the topic today. You had a few problems in homework that had absolute value. Okay? For the most part, if I recall correctly, I don't remember if it's 6.2 or 6.3. For the most part, they don't really do a whole lot with absolute value. Now, I do, if I'm not mistaken, I do think there's one that maybe needs absolute value tonight. But here's a phrase you'll start seeing a lot. You'll start seeing, assume all variables have positive values. If a variable has a positive value, is it going to need absolute value? No, because the whole idea of absolute value is to keep a variable positive. If they tell you in the directions that it's positive, you don't need absolute value. So a lot of times throughout the rest of the chapter, honestly, we don't use a lot of absolute value except right here at the beginning. So just kind of an FYI there. Still be on the lookout for a little bit, but I don't think you don't see it very much. All that being said, though, I do think there's one tonight. So I will pick up tomorrow on the backside, which is dividing, I believe. We'll talk about some dividing tomorrow. Homework will not be due till Monday. Okay? Doesn't mean you can't get started working on some of the multiplication tonight, though. Okay? Questions?